discussing on the topic non-conventional energy resource. Now, coming to the introduction of the topic, we all know that non conventional source of energy, also known as renewable energy, is a sustainable energy resource. Why we call it sustainable? Because it has lesser environmental impact, it is environment friendly, pollution free, and can be used year after year without its destruction. Key solution for future demand is also the non-conventional source of energy. The rate of replenishment by the natural process is equal or faster than the rate at which humans draw this energy from the nature. Therefore, also it is known as renewable energy. Now, coming to non conventional source of energy, we all know that they are always continuously available and also in some cases free to use by the human beings. So this energy is a solution to all environmental problem that we are facing in this century. So the tendency of the governments of all countries are to switch over from the conventional source of energy to non-conventional source of energy. Now, coming to the types of non-conventional source of energy, we can see that these types are solar energy, wind energy, biomass energy, small hydel power or hydropower, geothermal energy, and ocean energy. Here, a diagram or a pie chart showing the renewable energy capacity of India is given just to show that in India, we can see that about 45.1% of solar energy is produced, which is almost the greater section of all the non-conventional sources produced in India today. Then comes the wind power, which is also 23.3%, and the other small hydel power and biopower sources of non-conventional energy. From this diagram, what we want to represent is that India is not behind in generating non-conventional source of energy. Rather, India has excelled in various sectors of non-conventional sources of energy generation, and we will discuss it later on individually, coming to the solar energy at first. Now, coming to the advantages of non-conventional sources of energy, we can see the first and foremost advantage is environmental sustainability. Now, coming to the word sustainable, we know that sustainable means using a resource in such a manner or a judicious manner so that it is preserved for the future generation. Now, coming to the non-conventional sources of energy, be it solar, wind, tidal, biomass, anything, we can see that this energy generates almost no greenhouse gases. It is highly environment friendly and it does not create any pollution, and therefore it leads to environmental sustainability. Coming to renewability and inexhaustibility, these resources like solar and wind are free to human beings. We can get it anywhere in the world without any cost. Only what we need to do is we need to know the technology to harness it and convert it into a usable electrical energy or electricity or anything of that sort. So, renewability is a very important advantage as well as inexhaustibility, because we all know that this will remain on the earth's surface forever and ever. Energy security and diversification. Now, coming to this, the deployment of non-conventional source of energy reduces the dependence on imported fossil fuels like petroleum mainly that various countries import, and we can also diversify the energy supply. Low operating cost. Initially, while establishing the non-conventional source of energy plants, there is a huge cost, but the running cost is almost very low, and we can see that after installation, many renewable systems like solar, photovoltaic cells, wind have relatively low and very low operational cost and maintenance cost also. Now, coming to the decentralized energy access, we can see that renewable systems can be deployed at smaller scale, like in the rural regions where there is less development of urban facilities, and also improved electrification in remote areas or remote villages or mountainous terrain also. Then coming to the another benefit, that is public health benefit. Lower emission leads to lesser health impact because as there are no emission of greenhouse gases, therefore the cardiovascular health, associated water pollution, air pollution, everything is almost nil regarding non-conventional source of energy use. Now, long-term cost reduction can also be seen as a benefit of this type of resource. Although the initial investment is very high, but in the long term, we can see a lot of fuel saving, and the technological advancement nowadays are often resulting in reduced level of cost, that is LCOE, over the life cycle or the entire span of at least 25 years. Coming to the disadvantages of non-conventional source of energy, we can see that the first and foremost disadvantage is its intermittent nature and variability. Now, what is the intermittent nature? We can see that a non-conventional source of energy is very much dependent on natural conditions. Like, we cannot harness wind where there is no coastal area. Like, we cannot harness solar power in the Antarctic or Arctic region. So, the intermittent nature and the variability can be seen in case of non-conventional source of energy, and it is more or less location specific also. High initial capital cost, which I have already mentioned during the advantages, that initial investment for establishing a non-conventional power source or a power generating source is very high, like the wind farms or the solar photovoltaic cells. They are very much costly, and the establishment cost is even higher than establishing a thermal power plant or a conventional energy plant. Energy storage challenges. In case of non-conventional sources, we can see there is a challenge in efficient energy storage, example batteries, and these are very expensive and reduces the overall system cost effectiveness, and as well as the intermittent nature is also responsible for it. Land and space requirement. Large scale solar and wind installation can require large land areas. We all know that if we have been to states like Gujarat, where there are many wind power generation systems, large areas are required for its installation, and in some cases some countries cannot even provide so much area for this power generation. So it becomes a negative point after all. Now comes the location specificity, which I have already mentioned in the first point, that limited tectonically active region will lead to limited geothermal power generation. Again, the location specificity is also active in case of solar power. We know that the solar power is mostly active in the tropical, equatorial and subtropical region, while we cannot harness it in the polar region efficiently. So location specificity is another negative point. Now coming to another disadvantage, that is environmental and ecological impact. Initially, I have already said that it is environment friendly, but in some cases we can see that while establishing a hydel power or a micro hydel power project, we can see that it will disrupt the ecosystem in that area. Often we can see for establishment of a hydel power project, a village or two or many villages have to be reinstated or shifted from one place to another. Trees are being cut for establishing hydel power project, and we know many cases throughout the world where this phenomena has already happened. So environment and ecological impact cannot be removed from in this case of energy also. And technological and policy barriers, coming to this, the renewable systems require grid integration and upgradation as well as scientific know-how and supportive policies for its better generation. And to manage it, there are loads of optimization distribution. So for this reason, technological and policy pattern can also become a hindrance in case of generation of renewable energy. Now coming to the first type of non-conventional source of energy or renewable energy, that is the solar energy. We all know that solar energy is one of the most important type of renewable energy, and solar energy can be harnessed through electromagnetic radiation that comes from the sun, and using this the electromagnetic radiation, the sun's energy is trapped through the photovoltaic cells or the solar thermal collectors to produce electricity or thermal heat. Now, the mechanism involves two major patterns. One is the photovoltaic system, which converts sunlight directly into electricity using semiconductor materials, and the other one is the solar thermal system that concentrates sunlight to produce heat for water heating, industrial processes, or power generation. Example, the concentrated solar power. Now, coming to the distribution, we can see that the distribution of solar energy depends mainly on the latitudinal position of the country, the cloud cover, the atmospheric transparency, and length of the day. Now, one by one, latitude, mainly the solar rays are incident in the equatorial region, the tropical region, and the subtropical regions. Therefore, we can see in these latitudinal positions only the solar energy can be harnessed efficiently. Now, coming to the cloud cover, if there is a cloud cover during the rainy season, solar energy cannot be properly trapped or harnessed. Atmospheric transparency is also required to harness or trap solar energy, and the length of the day again becomes very important, because if the length of the day is more, then the solar energy transmission will also be more, and later on the trapment of this energy will also be more. Now, coming to the uses of solar energy, electricity generation is the primary use of solar energy. Other than that, water heating, agricultural pumps, lighting, solar cooker, solar desalination, rural electrification are other primary uses of solar energy. Now, the high solar potential regions include the tropical and the subtropical zones, the desert regions with clear sky, as I have already said in my previous slide. Major global solar belts receive high solar radiation, often above 5 to 7 kilowatt per meter cube per day. These are seen in Sahara Desert in North Africa, Middle East, Saudi Arabia, UAE, southwestern USA, California, Arizona, Atacama Desert, Chile, and central Australia. China is the highest generator or producer of solar energy. Then comes United States, third is India, then comes Germany and Spain. Here, the rank are given, and the diagram below, a bar graph, shows the comparative analysis of solar power to total renewable energy capacity in India. We can see that the solar power generation, which is represented in a deeper rust orange color, it has increased through years. From 2017, the bar graph has increased for both the cases. Solar power capacity has also increased, and total renewable energy generation has also increased. The data is shown from 2017 to 2024, and the source of the data is National Power Portal as of September 2024. Now, coming to the Indian scenario, we can see that India has a favored geographical location because it is a tropical country, and roughly between 8 degree north to 37 degree north latitude, the solar power yield is very high. About 4 to 7 kilowatt meter cube per day of solar power can be seen in India. Now, coming to the second category of non-conventional source of energy, that is wind energy. Now, wind energy harnesses kinetic energy of moving air masses using wind turbines, converting it into electrical energy via aerodynamic blades connected to a generator. Wind energy is the second most important renewable source of energy throughout the world. The site suitability is very important in case of wind energy. We can see that coastal and high altitude regions has consistent supply of wind speed. Therefore, wind energy can be established or harnessed in these regions. The advantages of wind energy is that there is no greenhouse gas emission, it has low ongoing running cost, and a scalable from small scale to a large scale firm. Limitations are also there in case of wind energy. We can see that the limitation is related to intermittency. As I have already said, that all renewable source of energy faces the problem of intermittency, noise generation through the turbines, and impact on bird migration, because birds get hurt due to the turbines that rotate during the generation of wind energy. Now, classifying the wind energy, we can see that the most common classification is based on its location. onshore wind energy and offshore wind energy. Onshore wind energy is that the turbines are installed in on the land surface, which constitute the majority of existing capacity because of easier access and lower installation cost, while the offshore wind energy can be seen where the turbines are installed in bodies of water, typically in the coastal areas, which benefit from higher and more consistent wind speed, but it involves higher installation cost as well as maintenance cost. Now, the wind energy production and distribution can be assessed in the world as well as Indian scenario. As of the end of 2023, we can see that the total installed wind power capacity worldwide exceeded 1000 gigawatts, driven by major markets such as China. Then comes United States, Germany, Brazil, and India. So we can obviously see that China contributes to about 40% of the entire market of wind power generation. Wind power contributes approximately 7.8% of global electricity generation as per the data of 2023. Now, according to the Global Wind Report of 2025, as of 31st March 2025, we can see that India's cumulative installed capacity of wind energy generation is about 50.04 gigawatts, and new additions of about 4.15 can also be seen in the financial year 2024 to 25. India ranks fourth globally in wind installed capacity, following China, United States, and Germany. Major wind generation or wind resource rich states include Gujarat, Karnataka, and Tamil Nadu, and these three states has a very high potential to generate wind power. The uses of wind power can be seen in primarily for the grid electricity generation in the hybrid system. Then comes the onshore wind farms, which supply bulk renewable electricity to industries, utilities, and consumers, displacing fossil fuel generation and reducing carbon emission. Then comes the offshore wind farms, which provides high capacity generation close to coastal load centers with consistent wind engine. So therefore we can see that wind power can dominate the electricity generation market, and if it is harnessed properly, be it in the world scenario as well as in India, we can see that wind power will grossly benefit the electricity consumption as well as less polluting factors of energy consumption. Now, coming to the third category of non-conventional sources of energy, that is the biomass energy. Biomass energy is derived from organic materials such as agricultural waste, residues, wood, and other biological waste. It is converted into heat or fuel, or like biogas or biodiesel or ethanol, through biological or thermochemical process. Now, globally, biomass supplies around 6% of total primary energy consumption. Now, the conversion techniques involved in biomass energy generation are direct combustion, gasification, fermentation. Biomass transforms the waste to low value material into a valuable product, like crop residues can be transformed into biogas or bioelectricity. Animal dung can also be transformed into biogas or organic manure. Municipal organic waste can also be transformed into energy as well as compost. It reduces open burning and associated air pollution and odor as well as related pollution problems. So, we can see that biomass energy is also a very important renewable source of energy, and its application can be seen mainly in heat generation, electricity generation, biofuel for transport, etc. Classifying the biomass energy, we can see that it can be classified into two types, feedstock type as well as the conversion technology type. The feedstock type include agricultural residue, forest biomass, dedicated energy crops, animal waste, organic municipal and industrial waste. And on the other hand, the conversion technology involves thermoclinal process such as combustion and gasification, and biochemical process process like anaerobic digestion and fermentation that yields biogas and liquid biofuels. Production and distribution of biomass energy can be analyzed in both the Indian as well as the world scenario. Biomass and biofuels account for more than 6% of the world's total energy, and we can see that it has a prevalent use in household cooking and heating, mainly in sub-Saharan Africa and Southeast Asia and South Asia. Biofuel production from biomass has become significant in Brazil and United States also. India produces 450 to 500 million tons of biomass annually. Biomass contributes approximately 32% of India's total primary energy consumption. Now, the uses of biomass energy are heat production from domestic cooking and industrial processes, energy generation in dedicated biomass power plant, transport fuel such as bioethanol and biodiesel, which reduces fossil fuel dependency in transport sector, and biogas generation from anaerobic digestion of organic waste for cooking and electricity. Coming to the next type, that is small hydropower or tidal power. Small hydropower energy system converts the potential and kinetic energy of flowing water or river water into electricity via the turbines and it falls under the non-conventional source of energy due to its lowest impact and ecological footprint. Hydel power has two major scales, one is large and one is small. The large one has been discussed in the conventional source of energy, and here we will discuss the small hydel power projects. It provides a stable and predictable source of power unlike the solar and wind, and contributes to energy security and sustainable development. Now, classifying the small hydropower project, we can see that by capacity, hydropower is classified into micro, mini and small hydropower projects. Micro hydropower is up to 100 kilowatt, mini hydropower is 100 kilowatt to 2 megawatt, and small is 2 to 25 megawatt. The uses of hydropower is primarily in electricity generation for local grids, small villages, rural communities, remote mountainous terrains, etc. It is also used in canal-based irrigation, power generation, improving energy efficiency in agricultural infrastructure. It also represents the sustainable, reliable, and environmentally compatible energy source. The production and distribution of hydropower globally is seen as 6 to 7% of total global hydropower comes from this arena. China leads the world in small hydropower development with over 80 gigawatts of installed capacity, followed by countries like Brazil, Canada, and United States, and several European nations like Italy, France, and Norway. In India, small hydropower distribution is also seen and mainly seen in the hilly terrain or the mountainous Himalayan regions like the states of Himachal Pradesh, Uttarakhand, Jammu and Kashmir, Arunachal Pradesh, and also it can be seen in the western and eastern Ghats like Karnataka, in the states of Maharashtra, Kerala, and Tamil Nadu. According to the Ministry of New and Renewable Energy, MNRE, India's estimated small hydropower potential is about 21 gigawatts spread across 7,000 identified sites or generating stations. Then coming to the next renewable source of energy, that is the geothermal energy. Geothermal energy is a bit rare because it is very much location specific, and this type of energy is a heat energy derived from the Earth's interior, generated mainly by radioactive decay of isotopes, mainly uranium, thorium, potassium, and residual heat from the planet's formation. This heat is stored in rocks, fluids and magma beneath the Earth's surface and is transferred upward through conduction and convection whenever any river or any water body comes in contact with it. The importance of geothermal energy lies in its continuous and stable nature, and the constraints again is location specific. Only the places which has hot springs and geysers can generate geothermal energy, and active zones or active plume zones can generate geothermal energy. So it is very much location specific. Now, coming to the classification of geothermal energy, we can see that according to temperature, geothermal energy can be classified into high temperature, medium temperature, and low temperature, ranging from systems like, in case of high temperature, the temperature is above 150 degrees centigrade, generating electricity. Medium temperature, that is 90 to 150 degrees centigrade, are used for both power and heating purpose. And the low temperature, that is below 90 degrees centigrade system, is mainly used for direct heating. Based on utilization, geothermal energy is also divided into electricity generation and direct use application. Electricity generation means dry steam, flash steam, and binary cycle power plants, and direct use applications are mainly space heating, bathing, greenhouse heating, and industrial processes. Coming to the distribution and production, the global distribution of geothermal energy is strongly associated with tectonic plate boundaries, volcanic belts, hotspots, geothermal gradients, and areas mainly around the Pacific Ring of Fire. As of 2024, we can see that the global installed capacity of geothermal energy is approximately 16.8 gigawatt. Leading geothermal powers producers of the world are United States, then comes Indonesia, Philippines, Turkey, New Zealand, Mexico, and Iceland. In India, geothermal energy distribution is linked to tectonic features such as Himalayan collision zone or the thrust or the fault zone, rift valleys, and volcanic provinces. In India, major geothermal provinces can be seen in the Puga Valley of Ladakh, Manikaran, Himachal Pradesh, Tapovan, Uttarakhand, Cambay Basin, Gujarat, Godavari and Mahanadi Rift Valleys, and Andaman and Nicobar Island. India has an estimated geothermal energy generation of about 10 gigawatt. The uses of geothermal energy are mainly direct uses, including space heating, district heating systems, hot water supply system, greenhouse cultivation, aquaculture, industrial drying, and balinology, that is hot springs and spas. Geothermal heat pumps also can be generated or used from this geothermal energy, which utilizes shallow, hot ground heat and increasingly used worldwide for heating and cooling buildings. Now, coming to the next category of renewable energy, that is ocean energy. Ocean energy refers to the renewable energy obtained from dynamic movements of seawater, primarily through tidal action and oceanic waves. The origin of tidal energy lies in the gravitational interaction between the Earth, Moon, and Sun, which causes periodic rise and fall of water level or the sea level, known as tides. And the importance of ocean energy stems from its vast untapped potential, long-term sustainability, and minimal greenhouse gas emission. It is highly predictable, making a renewable, reliable energy source. Classification of ocean energy can be done on the basis of tidal energy, the tidal barrage system, and the tidal stream system. The tidal barrage system uses dams across estuaries to capture the potential energy from tidal height differences, that is, the high tide and the low tide, while the tidal stream system harnesses kinetic energy from fast flowing tidal currents using underwater turbines. Wave energy systems are also classified based on device design, such as oscillating water pumps or water columns, point absorbers, and attenuators, which convert the kinetic and potential energy of rivers or waves into mechanical and electrical energy. The distribution and production of ocean energy worldwide can be seen persistently in those continental margins which are exposed to strong and periodic persistent winds like North Atlantic, North Sea, western coast of Europe, southern Australia, Chile, and South Africa. The global theoretical wave energy from tidal energy or wave energy potential is 2 to 3 terawatt. In India, tidal energy potential is concentrated in Gulf of Khambat and Gulf of Kutch of Gujarat, Sundarbans in West Bengal, and parts of Andaman and Nicobar Island. The estimated tidal energy potential of India is about 8 to 9 gigawatts. The uses of tidal power can be seen that the tidal and wave power can support remote coastal areas or islands and help in their electrification, reduce the use of diesel or petroleum and dependency on any sort of fossil fuel, and complement renewables in hybrid energy systems. The ocean energy can power desalination plants, offshore facilities, and contribute to green hydrogen production in future marine energy systems. Now, coming to the conclusion of the renewable source of energy, we can say that the non conventional energy source forms the cornerstone of sustainable and environment friendly, responsible energy for future. We can say that though our dependency is more on the non renewable source of energy and the entire world is sustaining on it, but we need more research, more technological innovations, know how, and researches on this sector of renewable energy so that we can generate a more sustainable and pollution free energy consumption sector for our future generation. And the non conventional source of energy is the only answer to a pollution free energy generation and a better future for all life forms on earth. Thank you.